Um, so we use SI, DI, DS, and ES in instructions. Okay. So this is actually the developer or the designer of the CPU design. Let's say so. This is for the operand. So this is for the string. Okay. So it is certain registers to do that operation. So the CPU, all right, won't have such a big load. All right. For example, if they want to process only a string, so it only focus on that register rather than searching for multiple registers. Okay. Uh, so to generate the physical address in the string, okay. So the CPU 86 always uses SI, okay. The register SI as the offset of the DS register, okay, and DI, okay, register as the offset for the extra segment register. Okay, so this is the instruction, the string operation. Okay, so we have the move a string byte. Okay, where we use the command of rep. Okay, rep over here. Okay, and we can also to move the string word. Okay, rep as well. And this is the mnemonic of that: move string word, move string byte. Okay, and so this is in terms of forward. So it will be in terms of different registers. Okay, so one is the capable of accepting tier 16 bit, okay, of string, and the byte only accepted until 8 bit of string. Okay, so you have the instruction of move, store, load, compare, and scan. Okay, so for compare, so you have the prefix as repe or repne. Okay, repe, repe, and e. Okay, so these are the instructions that you need to use in order for you to run the string instruction. Okay, in the string operation, okay, so before this, you have known that you have OF, the overflow flag, and also the carry flag, and also the sign flag is reflected, okay, to what you did. All right, but here in the string operation, the direction flag, okay, is affected. Okay, so the flag register bit 11, bit 11, okay, or D10 is set aside for the direction flag. So in the register, so at the location D10 is set aside for the direction flag. Okay, so the programmer specify the choice of increment or decrement by setting the direction of flag high or low. Okay, so you have another instruction, okay, CLD, to clear the DF. So you set the DF as 0. Okay, telling the string instruction to increment the pointers automatically. Okay, so whenever CLD set the DF as 0, okay, so the instruction will do the auto increment. So it will increase pointer by pointer. Okay, and then we have another command, okay, std, which is set the direction flag. Okay, performs the opposite function of that, meaning that the f now will become 1. Okay, so when the f becomes 1, that indicates that the pointer si and di, okay, should be decremented automatically. Okay, so reverse to the CLD. Okay, STD sets the DF as 1, CLD sets the DF as 0. So when DF is 0, the pointer increase automatically. But for STD, okay, the pointer decrements automatically. Okay, so we also have the REP, okay, REP instruction. The REP stands for repeat, okay, allows a instruction to perform the operation repeatedly. Okay, so REP assumes that CX, okay, the register CX holds the number of times the instruction should be repeated until CX becomes 0. Okay, meaning that, let's say you put the CX as 3, okay, and then it will decrease 1, okay, now CX equals to 3, CX equals to 2, to 1, and then to 0. Okay, so it tells you how many times that the instruction should be. Okay, so we look at this example. Okay, okay, in this example, we use string instruction to write a program to transfer the block of 20 bytes of the data. Okay, so we have the data. Okay, so we have A, B, C. Okay. So how many bytes of data that we have here? So we have 20. Okay, so we have 20 bytes here. So A up to T, we have 20 bytes of data. Okay, so first we initialize this data, all right? So move A, AX. So AX is we want to initialize the data segment. So we put AX into the DS. Okay, and then we also need to initialize ES. So ES, as I mentioned before, it is related to the SI pointer. Okay, and also DS is related to the yes, DS. As before this. Okay, so okay, SI is related to the DS register and DI is related to the ES register. Okay, so DS, okay, so we need to initialize the data segment, and ES we initialize the extra segment. Okay, and then we did CLD. Okay, so when we did CLD, meaning that we need to increment. Okay, we need to increment the direction flag. Okay, so it will increase one by one. Okay, the direction flag. Okay, sorry, the pointer. All right, the pointer will increase one by one. Okay, so meaning that here, so we have the data one over there. Okay, so we need to, okay, so because we have 20 here, so we need to increase one by one until 20. Okay, until 20, but we need to, okay, because this is the counter, the CS is the counter, so we need to decrease CS one by one. So we use repeat statement, okay, and then move SB. So the move SB instruction, okay, is, okay, the one that we want to move. We want to move, okay, the byte, okay, is incremented by one. Okay, so mean that here the repeat prefix causes the CX counter to decrement, okay, and SB is repeated until CX becomes 0. So meaning that this is repeated, okay, again up to 20 times. Okay, so when we have that, meaning that, so it will transfer one by one. Okay, it will transfer this one. Okay, A. For example, A will go first. All right. Okay, for example, A goes first and then next takes B and then C, D until 20 times. Okay, so meaning that this statement is repeated for 20 times. Okay, so what we have here is because X is 20, so CX will decrement. Okay, so this will affect this REP to be giving the instruction of move SB, okay, move SB up to 20 times.
Doctor,
Yes.
can I know it move SB to where? To transfer to where?
Okay, you look here. Okay, so so for the source to the destination over here, so meaning that it will go to this data too. Okay, it will go to the data too.
Okay, okay,
So
thank you.
this is where the data contains, right, the initial here. But here, okay, it will accept 20, right, 20 bit, 20 bytes. Okay, so this data 20 bytes. So this is the source. So this is the source. We'll go to this destination. Okay, the data too. Okay, so to generate this pointer, so you must first initialize the DS and ES first. Okay, so ES for DI and DS for SI. Okay, so you specify that in terms of uh, this data too, offset data too. Okay, so meaning that it will do the auto increment when we have this element CLD. Okay, so you can also change the way you want to do the programming when you can use the move SW. Okay, move SW. Okay, here you use move SB. SB stands for byte. Okay, so byte you can implement one by one, but when you use W word, okay, you can transfer the word. So meaning that you can transfer up to 2 bytes. Okay, meaning that you transfer AB, okay, together, and CD, okay, GH, okay, and so on. Right. So you move this REP move SB command. Okay, so it will increment, okay, the SI and DI register each twice. Okay, so 2, 4, 6, 8, and so on. Okay, so because of that, okay, so this, but the CX will decrease only one. Okay, because so from 10 to 9 to 8, but the thing is that the byte that is moved is 2. Okay, A, B, C, D, E, F, G, H, and so on. Okay,
Doctor?
so we have another instruction, uh, STOS. Okay, STOS byte. Okay, so if STOS byte, okay, so you just need to know that in the string operation, that usually one letter, okay, let's say A, is considered as 1 byte. So but A can be defined in terms of hex, right? As you remember, that you learn, okay, from the keyboard, right? So you can transform that. For 1 byte is 8 bit. Okay, as you remember, 1 byte is equals to 8 bit. So it will fills the, in terms of binary, it will fills 8 location. Okay. All right. So we have the STOS. Okay, is to store the byte in register AL into memory location pointed at byte ESDI. Okay. So this also effect based on the flag. Okay. So it will look at the direction flag. If the direction flag, okay, is 0, then DI is incremented once. Okay. But if the F is 1, direction flag is 1, then DI is decremented. Okay, also 1. Okay, complement to that, so we have S2 SW, okay, where it will increment the bytes 2 times. Okay, 2 bytes by 2 bytes and 2 bytes. Okay, so the STOSW, okay, store the contents of AX in ESDI. Okay, so we need to use AX now because word accept 6. Okay, so we need to accept. We need to use AX rather than AL. Okay, so store that in the ESDI and ESDI plus 1. Okay, so the content of will be in the ESDI. Okay, and the content of ESDI plus 1 will be in the AH. Okay, well, it will depends on the direction flag whether we want to do the incrementation or the decrementation. Okay, and it will be done twice because of word. Okay, STOSW. Okay, we also have the instruction of load. Okay, that is LODS for byte. Okay, so as usual, it will increment the load 1 by 1 or decrement 1 by 1. So that depends on the DF flag. And also for the word. Okay, so you have the instruction of LODSW. Okay, so similar like store. So you have the DSSI, okay, and also DSSI plus 1. Okay, so it is incremented twice based on the direction. Okay, the load, but it does not use the repeat prefix. Okay, so we look over here. Example. Okay, so we want to put this pattern AAAH, okay, the hash number in 50 words location. Okay, so we initialize AX. Okay, so AX we put into the DS and also ES. Okay, and then CLD. So CLD means that we clear DF. So now DF becomes 0. Okay, for increment. Okay, so we need to set whether you want to or we want to decrease. Okay, so if we want to decrease, meaning that we already have the information is stored at those register. Okay, but for example here we don't have the so we want to put the information into this location. So we need to increase the DF. Sorry, we need to do the increment. So that's why we need to set DF as 0. Okay, so we're gonna put into 50 word location. So we need to do the counter. So the counter will be CX is equals to 50. All right. After, okay, so what we're going to put, okay, so we have the S and ES, right? So first, we want to, okay, so we want to have that, okay. So DI is, where is the location that we're going to put that, right? So this is the destination, because DI is complemented with the ES. Okay, so first, we move this AH into the AX, okay, and then we want to use the command store, okay, store word. Okay, so it will store, okay, it will store at two locations, so it will increment twice. Okay, so we use the repeat statement, so it will increment one by one until it is increment until 50 times. Okay, so why 50 times here? It is not 25, because it says that 50 word location, so it's not 50 byte location. So if it is 50 byte location, so of course we just, if we use STOSW, then CX we need to set as 25. Okay, so that's the important one, right? So for the bottom one, I'm not gonna cover it because it is not important. Okay, so you get the idea on how to store, right? Store this information into the word location. Um, all right, so we also have REPZ and also REPNZ prefix, okay? Repeat 0 and repeat non-zero, okay? So this is used for use with the instruction of CMPS and SCAS. Okay, so we also have the REPE, okay, repeat equal. Okay, so the meaning is that it will repeat the string operation as long as the destinations operands are equal. Okay, so if the source and destination operands are equal, mean that when we do the compare CMP, destination and source are similar, so we have the 0, 1 will be 1, okay, so will be 1, so it will do the repetition, okay, or until CX becomes 0. Okay, so we also have the instruction of repeat not 0, okay, so rep NZ, okay, so this is also similar as REP and E, not equal, okay, repeat not equal, so it will repeat the string operation as long as the source and destination operands are not equal. Source and destination operands are not equal, so the 0 flag is 0 or until CX becomes 0. So we have the instruction of CMPS. CMPS stands for compare string. Okay, CMP, CMP is for S is for string. Okay, allows the comparison of two arrays of data pointed at by registers SI and DI. Okay, so CMPS can test inequality of two arrays using REP and E. CMPS B. Okay, B is 4 byte. Okay, so we have the SCASB. Okay, SCASB is scan string. Okay, SCA scan and string B is byte. Okay, scan string byte. Okay, compares each byte of the array pointed at by ES DI with the contents of the AL register. Okay, so SCASB can be complement with REPE or REP not equal. Okay, so whether that decision you want to find the equal string or not non-equal string. Okay, so I don't know if this example here, they give me a minute to check. So we don't have that. Okay, by the way, give me some time. All right, so we go back to the example shortly. So let's finish this first. Okay, so we have the example. Let's say we want to compare the letter G. Okay, compare with M. Okay, in the example. So it will show you on how to perform that. Okay, you also have the SCASB. Okay, so we search for a character if an array, and if found, it will replace with the desired character. Let's say you want to find, okay, in terms of, let's say I put makan. Okay. Okay, so let's say to replace this, we want to find here letter M. Okay, we want to replace that with the big M. Okay, so we want to replace that with the big M. So we need to use SCASB instruction. Okay, SCASB instruction with the prefix. Okay, REPE or REPNE. Okay, so if we found M here, and then we can do the replacement with the character that we desire. Okay, so last one, we have the XL80 instruction. Okay, so we have that SL80 instruction. So SL80 is for the table. Okay, so before this we discussed about the string. Okay, now we discuss about the table. So to access the element, so we provide the XL80 instruction. Okay, the translate instruction. So XL80 is the translate instruction. For example, we want to find out, we need a table, okay, for the values of x squared, okay, where x is between 0 and 9. Okay. First table is generated and stored in memory. So let's say we define that table. So this will be, okay, from 0 up to 9. So 9 squared is 81, 8 squared is 64, 7 squared is 49, and so on. Okay. So to access the square of any number from 0 to 9, So we use the XLAT. Okay, and register BX must have the offset address of the lookup table. Okay, and the number whose square is sought must be in the register AL. Okay, so after the execution of the XLAT instruction, AL will have the square of the number. Okay, so it is like this one. Okay, so we have that offset before. Okay, so we call that offset. So we move into the BX. Okay, so BX offset address of the lookup table. Okay, now BX have the access of the offset address of the lookup table, and then we what is the element number 5. Okay, we want to so we want to know, okay, what is the square of 5. Okay, so you want to define what is the square of 5. So we put let's say we define that AL as 0.5. Okay, and then XLAT will find, okay, on this SQR table, okay, that having the square of this AL. So meaning that it will find 25. Okay, so that is the function of XLAT. Okay, for example, we put AL is 0.9, so it will find 81. Okay, it will find 81. Okay, so XLAT, okay, is one instruction. Okay, so it is this one. Okay, so meaning that it's like this. Okay, you can also replace XLAT with this one if you want. Okay, so first we move AX into SI. Okay, and then of course this is the we get the entry, okay, pointed by those BX, okay, by those BX inside those. All right, so meaning that we check, okay, what is the element of BX that is equals to 0.5. Okay, so for example here we will look up to 25 because it's square of that. Okay, so it's okay, you put 0, 1, 2, 3, 4, 5. Okay, so that's how it is related to that. Okay, for the fifth element on that instruction, okay, on that operand. Okay, so this is the meaning of the XLAT. Okay, so XLAT also can translate the hex key of non-ASCII keyboard to ASCII. Okay, so assume that program. So we have the keys of 0 to F. Okay, so the following is the program to convert the hex digit of 0 to F to their ASCII equivalent. Okay, so this is what we have for our ASCII, right? So we have the hex digit. Okay, so we have the hex digit of 0 up to F. Okay, so you know that for keyboard, okay, so for your keyboard, you have the hex values, all right, for each of the key. Okay, so you need to first we need to move this into the BX. Okay, so BX have the offset address of that. Okay, and then we put the hex value. Okay, so this is what is the hex value of that. Okay, let's say so this is combination of that. Let's say it can be 0, 0, okay, 0, 1, okay, maybe FF. Okay, so that's the hex value that we fill in that one, and then we put XLET, okay, and then it will give you the equivalent of the ASCII value. Okay, so because hex value is put into the AL, and then AL now is put into the ASCII value. Okay, so it will be equivalent to what we have there. For example, so let's say this is 0, this is B and C and so on. So like the key that you have on your, okay, so that's another usage of the XLET. For the chapter 6, we're going through, give me 1 minute to show you the example of 16. Okay, so this is what you have the example of 16. Okay, so for the example of 16, you want to write a program that scans the name of Mr. Gones, replace G with the letter J. Okay, now you want to make it Mr. Jones, right? Okay, so as usual, we declare this into the database, all right, in the data segment. So data 1, Mr. Gones, okay, all right, and then after that, you call that data into the AX, and AX into the DS, and AX into the ES, okay, and CLD, because we want to increment, right? So we want to read one by one of the byte. Okay, so this data one we put into the offset address of the DI. We put that into the offset address of the DI, and then we know that the length, okay, the length of this is 9. Okay, so it is including the space, all right? Mr. MR123 and dot 4, okay, and the names have 5, so it's 9 times, so you need to repeat that, okay, and then it will check with for the letter G, okay, so you put G inside the AL, okay, and then you put REP not equal, repeat not equal, scan byte, okay, so it will scan one letter by one letter, okay, so meaning that this statement is repeated, okay, is repeated as long as it is not equal to G, okay. So first it will look, okay, M, okay, first M is not G, okay, so it will repeat, okay, and then next is follows, okay, it is still not similar to G, okay, it will repeat, so it will repeat until 4 times, and then the 5th times, okay, the G, and then this statement will stop, okay. Okay, and then okay, after that, jump not equal. Okay, jump not equal. So if not equal, okay, it will repeat. Okay, it will goes to the, okay. So mean that if it is not equal to that, okay, not equal to whatever is searched, and then it will go to over. So once over, then you already have the data is already fixed, okay, because you cannot see anymore the letter G inside that, okay, because it keeps scanning. It is not similar, okay, it is not similar to that because it's already replaced, okay. So first, before we go into over, okay, it will jump to that, okay, but now it won't do the jump because it will go to the next statement, okay. It will go to the next statement, okay, and then it will decrement the counter, okay, one by one, okay, and then it will decrease. It will do the decrement. And then move that J, okay, into that DI. So meaning that it will decrement to point at G. Okay, meaning that this will be replaced. Okay, this will be replaced. So we put that J into that DI. Okay, we put that J into that DI. Okay, and then after that only, okay, after that only it will go to the next instruction. Okay, if it does not still find that letter G, so it will, this statement will keep, okay, repeated. Okay, rep not equal will be repeated until it will find that letter G is there. Okay, well, how about if the letter G is not there? Let's say we put Mr. Zone, Mr. ZONES, zone. Okay, of course, this, it will keep repeated again and again. Okay, and then jump will not occur. Jump will not occur because there is no of this statement will be executed because it will not be replaced. Okay, it will not be replaced. Okay, all right, one more example is how we can replace
Doctor.
yes.
For the code in the bottom below the semicolon or, does it replace the one on top or it's added?
It does not replace all of this, okay. It is either of that, okay, either of that, okay. So meaning that it's still valid up to here, right?
Up
It
to
is still,
CX9, move CX9.
yes, up to here, right, up to CS9. Okay, and then after that it will um, follow this one, okay, until this one, okay, until this. Sorry, it will check until move ALG, okay, or this is replaced, okay, REPNE as CASB with JNE over.
So just the last line, Doctor.
Yes, this REPNE and also JNE, but this one is still there because you want to replace that with J, right? So, but the letter up here, okay, does not do the replacement, okay? So it just scan the letter, okay? So you can either use REPNE, okay, or you can use the jump instruction. Okay.
Okay.
Okay, so is it just between these two, whether you use RAPNE or you use JNE? Okay, so if you use RAPNE, so you don't need to use jump instruction. So it will go to decrement DI. So it one by one. Okay, so DI, and then because RAPNE will go through up to 9 times. Okay, up to up to times where it found the statement G is equals to what you have here. So as I mentioned before, it will go up to 4 and the fifth times. Okay, for the fifth times, it will find. Okay, it will find that G is there. Okay, and then it will move to DEC DI. Okay, decrement DI. So it will remove that. Okay, and then it will replace that with J. Okay, and then it will show the display after that. Okay. Uh, okay, so this is a simple replacement for that. Okay, let's say we want to find the letter G inside. We want to find the letter G inside the code. All right, we want to find the letter G inside the code. So we just go up to the REPNESCASB. Okay, so if we don't want to do the replacement, we just want to do the searching. So we just use the code up to here. Okay, REPNESCASB. Okay, so that is the example about SCASB. Right, so that's the chapter 6. Okay, any questions so far?
Not yet, Doctor.
All right. Okay. So for Thursday, you're gonna have the quiz. All right, on the assembly programming. Okay. So basically, it will test about the simple instruction. Okay, it will test for the simple instruction, and then you need to record. Okay, you need to record what is the result from your finding. Okay, so let's say the example is that ROL, okay, AR, okay, SHR, something like that. Maybe you can also use SCA, SB, something like that as well. Okay, so you just need to type out and then check whether the results is similar to what you understand. Okay, during the class. Okay, so for your final exam, so it will cover up to the end of this chapter. Okay, I will give you some tips later. Okay, about there will be 6 questions in the final. Okay, there will be 6 questions in the final. So the total marks will be 60. Okay, so it will be for 2 hours. I'm not sure if you, I think in the evening, right? 2:30 to 4:30, if I'm not mistaken. Okay. So maybe if it is in evening, then if you don't have any exam after that, maybe I'm gonna give you another extra time, okay, for you to complete the exam. Okay. So mostly the chapter covers the information on the last 2 to 3 chapters. Okay, so meaning that it includes the what you need to know about the interrupt. Okay, interrupt. So mostly you need to know what does interrupt do. Okay, starting from int 10, int 21, okay, int 33. Okay, so you need to know how to use the interrupt. Okay, and then you need to know on how to analyze the program given. Okay, so let's say you're given this code. Let's say if you want to edit those, where you want to edit those. Okay, something like that. Okay, let's say you want to add more instruction to that. So at which line you should add that. Okay, for example, like this one, you want to perform the addition instruction. Okay, for the AX, for example. So how do you do that? So at which line that you should put that instruction. Okay, or let's say you want to change the color of the screen. Okay, so where you want to put that. Okay, so you need also know the function of each code. Okay, of each code given. Okay, for example, this instruction for moving the cursor. All right, the next instruction is to show you that you press key on the keyboard. Okay, this instruction to show that you video resolution. Okay, so another instruction you want to display the message. Okay, okay, another instruction you want to scan the string. Okay, so you need to know that. So that's the really important part of the exam. Okay, any other question? All right, I think I have covered most of that many for the final. Okay, so I wish you good luck for the final exam. So I'm going to give you the example. Okay, example problems uh, of this chapter as well, and then the okay. So that one will be included to the Putra Plus later. Okay. So basically, it is end of the chapter problem. Okay. So that one will be given together with the answer, so you can practice on that. Okay. Right. So if no question, then I'm my lecture here, right? And then if you have any further question after this, you can just WhatsApp me. Okay. So let's turn on your camera for me to take your attendance for today. Okay, one thing, remember that you need to submit your presentation video on to teach at least 5 of the instruction, okay, that you learn, okay, in the class. Okay, so that will be due uh, Friday, okay, next week. Okay, Friday next week. Okay, so you need to upload that in the YouTube, and then you can share me the link.
Doctor, does it need to show our face? Do we
Pardon?
need to show our face? Or maybe we can record like example whiteboard. We're talking.
Yes, you can do the recording and then you can upload to the YouTube.
No, I mean, doctor, do we have to show our face in the video?
Yes, you must
I
show
must
your
show.
face.
Okay.
Okay. All right. So, okay. I'm going to count from 10. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, cheers everyone. Okay. Okay, have a nice day. All right. I hope you can do your best on the final. Okay. Assalamualaikum and bye-bye.
Thank you, Doctor.
Thank you, Doctor.
Thank you,
Thank you,
Doctor.
Doctor.
You're welcome.